had some flat earthers, okay, and they had all kinds of problems understanding the question, and they still have problems understanding the question. They think they understood the question. They said, "But we answered the question, Bill." And no, you haven't. You haven't even understood the question. So let's find out what they don't understand. And I'm going to go quickly through these. Here's the first one. Fellow says, fell on the other side. Give me a second here. Here's the first one. Says, during acceleration, the air in the car has a higher density in the back of the vehicle than it does in the front. Remember, the balloon goes forward when you accelerate instead of backward, as intuition would tell you. And the idea is that all this air that accumulates in the back pushes the balloon forward. So the question was, why does the air go back or stay in its place while the car accelerates? No one understands the question yet. This guy just says, higher density in the back. Yeah, we know that. You have to explain why there's higher density in the back. Okay, it says this means that the net force on the balloon due to collisions with the air will be in the forward direction. Yeah, that's what happens when people don't understand the question. They just repeat the same description. They say, well, air goes back and pushes the balloon forward. Yeah, we know that. So please don't answer what hasn't been asked, or don't answer with a description which we already understand, know, and have already put forth. Another fellow says the balloon isn't pushed forward without a roof on the car. So he's saying that it's the roof that pushes the air, right? The car is the container. Yeah, we know that. Separating the system off from the outside. Yeah, we know that too. So it's isolated. So the motion of the container allows for the accumulation inside the sealed container. And again, it doesn't understand the question. The question is, why? Why does the air accumulate in the back, when the car accelerates? Okay, it pushes the first few atoms or molecules, fine. And the question is, why are the other ones waiting? We're not concerned about the ones that are being touched by the car, the window, the roof. We're concerned about the ones that are standing still waiting for the car to reach them. And still didn't understand probably, okay? But that's the best way I can explain it to them. The question, this is 5 weeks now, I've been trying to explain the question. That's just unbelievable. Okay, and same fellow says, question, what is the mechanism to make air accumulate in the back of the car? Yeah, that's the question. Do you understand the question? No, he doesn't, because he says, the structure of the car and window does not allow air molecules to transmit through it. No kidding. Did you figure this out all by yourself? You must have had help. I don't trust people. They get help. It says, structure of glass preventing an oxygen molecule from passing through it. This is what they answer, that air cannot go through glass. That's why it accumulates. Okay, same fellow. He goes a little further. Okay, he says, why does the air molecule stay where it is? Yeah. That's what we want you to answer, okay? It says the structure of the atmosphere where there are trillions of other molecules holding the total system in place until a force disturbs it. Physical mechanism, structure of the atmosphere similar to being in a child's ball pit with extremely tiny balls. So he's saying one of the two. It's either the glass of the back of the van that's pushing the molecules forward, or that it's the other molecules that are pushing the molecules forward. So he hasn't answered he doesn't even understand the question yet. 3 times, he answered 3 times, he never fixed the problem. He doesn't understand the question. This is 5 weeks that this fellow doesn't understand the question. No, the question is, he asked the question, but he doesn't understand what he's asking, what the question is. The question, why does the air molecule stay where it is? Okay, so you have some molecules that are being touched by the car as the car accelerates. Meanwhile, you have other molecules that are waiting for either the molecules or the car to smash against them. Why are those molecules that nothing has touched them yet, why are those standing still? Why are they still in place? Why haven't they moved? I mean, they move a little bit. We all recognize that. They move a little bit, but they don't move at the speed of the car. The car is squashing the molecules that are closer to the window, and they're pushing them all together, so that's why the density accumulates. But until the car runs, we have some molecules which are standing still or moving back. Some people believe that they move back. We're going to argue here that they stand still. Okay, so we have molecules pushing, but some are standing still until what they say, a force? No, there is no such thing as force. No physical object called force. Until the back of the car or other molecules of air push them. Okay, but until that happens, these molecules are standing still, waiting for something to hit them. Why are they standing still like a tree stuck to the ground? That's the question. 5 weeks now, they still don't understand the question. And I'm not sure they still understood it yet, And a fellow says, couldn't it be the walls of the car hitting an air on all sides? Same thing. These people are saying the walls are hitting the molecule. No, the question is, why are the molecules standing still until the wall hits them? Okay, so they don't understand the question. It's unbelievable. These people are mentally retarded. They don't understand the question. And yeah, they just have this second nature that they say, well, it is so. The molecule's there until something hits it. A force, they say, a force. It could be a horse, maybe. Man, that's what they're talking about. There is no physical object called force. So why these people use the word force, I have no idea. There's no such thing as force, no such thing as density, no such thing as gravity. Okay, you have to identify the physical object that comes in contact with the molecule. And it could be other molecules, it could be the glass or the back of the van, that we can accept. You can say the back of the van, the wall, the glass hit the molecule. That we all understand. And you can say other molecules of air hit the molecule of air that was standing still. We can all understand that as well. The issue is until something hits it. Why? What keeps that molecule standing still? And people think that, well, it should stand still until a force hits it and moves it. Not true. You have not justified that. You're just repeating stuff that you don't understand. Okay? You're just saying it is so. That's all you're saying. There is no reason for a molecule to stand still. Now, in the case of the tree, you say, well, I know why that stands still, because it's stuck to the ground and it's a rigid entity, essentially, so the tree doesn't move with a car. Especially if, like I showed you a couple of weeks ago, you build the van on top of the tree. So the tree is inside the van, right? So it's inside the van. It's not touching any part of the van. But when the car or the van accelerates, the tree is left behind because it's stuck to the ground, even though it's inside the car, just like the molecule. But the molecule is inside the car. It also stands still, just like the tree. In the case of the tree, you say, well, it's because it's stuck to the ground. So is the molecule stuck to the ground also? That's the question. So Phil says, the question you're asking about why objects stay behind is not related to the container moving. Finally, one person who understands at least the question. Yes, the container has nothing to do with the whole question. So don't tell me the container, and don't tell me that the molecules that have bundled up in the back of air, that they're going to push the molecule. Forget about all that. You have to tell me why that molecule stands still until something hits it. That's the question. If you can understand it. Why doesn't the air spontaneously move to one side of the container? Because on average, the summation of random motion is 0. So this fellow is saying, yeah, it stands still and it's got nothing to do with the container. Okay, great. We understand that. That is, you got a little head start over the other fellows, okay? But how does he answer? He says the average motion. That's not a question. That's not an answer. You can't say it's the average motion. That's mathematics. We need to know what physical object either keeps the molecule in place until what other object hits it and moves it. Okay, so the question is why? What causes the molecule to stand still? You're making an assumption that it stands still, but you're not telling me what causes it to stand still until something hits it. And you just take it for granted. It stands still until something hits it. Not true. Absolutely not true. Nothing stands still in the universe. Okay, so you got to tell me why it's standing still until something hits it. And if you take it for granted, you're making the wrong assumption. You're making an irrational assumption. Okay, so that's the issue. Okay, so here we're going to illustrate it one more time. Maybe someone understands it finally. Okay, here it is. Here's the pencil. Okay, and you can see the pencil doesn't bunch up at the back of the van. In other words, all the atoms do not, or molecules, they do not create higher density in the back. Why? You say, well, it's because it's a rigid entity, so all the molecules, all the atoms of the pencil move at the same time, okay? And again, it's got nothing to do with the pencil going through the window, like some people say out there, okay? So you can see the atoms are being pushed all simultaneously, and you say, well, because it's a rigid structure. That's why you say, that's why they all move forward at the same time. Okay, but here we did it with water the other day. Okay, we moved this rapidly, water in a container, and you can see that there's going to be a gradient of water, and it's going to accumulate in the back. There it is. Okay, very quickly you can see the water moving towards the rear of the container there, and you can see there's this gradient of water. It all moved backwards. Okay, so the question, why did all that water accumulate in the back? That's the first question, but the real question we want to understand is why did water stand still, the water molecules, until the back of the container hit it or other water molecules hit it? Okay, that's going to be the question. Let's see if we can understand the question. Okay, and here it is illustrated. Okay, we're going to accelerate the van. Okay, and you can see some molecules stay until something hits it, until something hits it. The question is, why, until something hits it, does it stand still? Okay, because we can all understand the back of the van hitting molecules and piling them up. We can all understand that. We can all understand why molecules of air are hitting other molecules of air and bunching up. Those part we understand. That is not the question. The question is, why do the ones that say stays, why do they stay? What keeps them in place is the question. Okay, that's the question. I'm just trying to get people to understand the question. So let's stand still. Let's force this thing to stand still. Here it is. Okay, you can see the three molecules in the back are being bunched up, while the other ones are still in their normal state essentially. Okay, until either a molecule of air or the back of the truck hits it, that molecule stays in place. We want to understand why the molecule stands in place, what keeps it there. And don't tell me it stays there until something hits it, until there's a force, because it means you have to go to see a shrink. Okay, you got mental problems. You're making an assumption that is invalid. Okay, so you cannot say the molecule stands still because. No, everything is caused, and standing still also is caused. That's the issue. Okay, how do we explain it with a rope? Very simple. We explained this in the past. The molecule stands still because that molecule is stuck to every atom on Earth. Every atom on Earth is stuck, is pulling on that molecule. That's essentially the reason it stays more or less in the same place until something like the truck hits it, or another molecule, set of molecules, air, bunches up and pushes out, pushes the molecule forward. Okay, and here you have Mr. Muller again, just in case. So for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. Please repeat this every night as your prayer. Every atom on Earth, okay, is pulling on every atom of you. You're also pulling on it. You have to memorize that mantra because you're not understanding what this man is telling you, okay? And until you understand that, what he's saying there, every atom on Earth is pulling on every atom of you, and you're also pulling on it. Unless you understand what that's telling you, you won't understand why that molecule stays in place. It stays in place because every atom on Earth is bound to that atom, and that atom is bound, pulling on every atom on Earth. So it more or less stays in place. That's what keeps it in place. The assumption that you have in your tiny little brain that until a force pushes, it stays there is irrational. That's what's irrational, okay? And it takes a long time for these mental cases to understand that, flat earthers. Okay, the fellow says, according to your rope hypothesis, the air molecules are connected to the container as well as the rest of the universe. Yeah, correct. When the container accelerates, there should be a small net force, assuming shorter ropes have more effect than longer ropes. No, they don't. Accelerating the air molecules in the direction that the container travels. Conventional science does not support this. Yeah, neither does the rope model, because again, this individual does not understand the rope model. He hasn't done a minimum of research. Here's our version. The atoms slide along a rope as they eat into the rope, link by link. Okay, so an atom moves like a bead on an abacus. It slides without dragging the rope behind it. The ropes are always taut. They're pulled tightly between any two atoms, pulled by every atom in the universe. That's why it's so tight. The speed of light is a measure of that tension, and the speed of light is constant. That's why it's a constant tension. And all you have is an atom just sliding along the ropes. Why? Because the atom is made of those same threads. Okay, there's a single thread in the entire universe. So until you understand the foundations, the basics of the rope model, you cannot even, come up with these scenarios because you don't understand enough about them. Okay. Okay, and then a final issue related to the van and to the air. Here it is. Fellow says, if we can ignore the effect of gravity, do the air molecules follow a straight path relative to the Earth or a curved path influenced by the acceleration of the container? In other words, he's saying if the van pulls or drags or pushes all these molecules of air, do the molecules stay straight or parallel to the Earth, or does it go in the direction in which the van goes? So if the van goes on a curve, do the air molecules still stay straight and the van just goes sideways? That sort of thing. That's what he's asking. And so he continues, says, therefore you have the basis of an experiment to test the validity of the rope hypothesis. Well, the first thing is that in science we don't test anything. We don't prove, we don't verify. Okay? We don't do any of those things that they do in mathematics, because we're talking about invisible, intangible entities. There's no way anyone can prove to you, can verify for you through see or touch, through an experiment. create some evidence for you that the rope exists. Okay, the rope is invisible and intangible. In fact, atoms individually, individual atoms are invisible and intangible. You can't see a hydrogen atom. Okay, so you can't see or touch. You might touch it, but you won't know. So you said, did I touch it or not? You won't know. You won't know if you touch the hydrogen atom. Okay, so prove to me that you touched the hydrogen atom. You touched the table, which contained a hydrogen atom, but I don't know, maybe you touched the carbon atom or who knows what. We don't know that you touched the hydrogen atom. So you can't see or touch an atom, let alone the rope, which is gazillions of times thinner than an atom. Okay, so forget about see touch. You're talking about something that's beyond the Planck length. Okay, or Planck width or Planck energy or whatever. There's no way to see or touch that. It has no ability for a human to see or touch the rope. Okay, so no experiment, no evidence. You'll never find evidence. This is something that you conceptualize, you visualize, you imagine. Okay, so you can't see or touch it. Especially because it's invisible, intangible, and meaning that if you have that notion of the word object, you have an irrational notion of the word object. Not all objects can be seen, not all objects can be touched. And so the question for you, are there noumena? In other words, like phenomena means the stuff that you can see or touch. Noumena are stuff that you cannot see or touch. And again, these are like, who was it? I'm trying to remember the philosopher who said that it's an object of the mind. You can only conceptualize it. You can imagine it. You can try to visualize it. That's it. So that you understand how the universe works. That's where it goes. It has nothing to do with going to the lab and touching and seeing. So you will not determine this through an experiment. Anyways, the car, the container, will take the air with it. Okay, so he asked there, if the car accelerates, what will happen to the air? Will it go straight or curve with the car? It's very simple. Why does this person have so much problem? This is very straightforward. The car will drag the air with it. Okay, just like I'm dragging this wand with my hand because I'm pushing against it. Well, the same thing with air, no different. So these people have, I don't know, really big problems in their minds. They're irrational folk. They're probably, again, flat earthers and electric universers.